We're going to talk about how to graph exponential functions. So when we talk about exponential functions, we have our parent function, which is f of x equals b to the x. And b is greater than 0 and b does not equal 1. Okay, so that is the parent function for the group of exponential functions. So let's look at a specific example where b equals 2 so that we can talk about some key characteristics. So when b equals 2, we have the equation f of x equals 2 to the x. So when we talk about this function, notice that the x-axis is an asymptote of the graph. So here's the graph of f of x equals 2 to the x. So notice that this graph is going to get really, really close to the x-axis, right, which has the equation y equals 0, but it's never going to actually cross it. The domain of this function is going to be all real numbers. Notice that when we look at this graph, it includes all x values, including negative values, 0, fractions, decimals, everything, and it's continuous, okay? So it's going to include all real numbers going from negative infinity to positive infinity. The range is going to include all real numbers that are greater than 0. So the range will go from 0, but notice that I have an open set right there, right? So the 0 is not included because the reason is that 0 is not included in my graph, right? We have an asymptote at y equals 0, so the actual value of 0 is not included, but everything up to it is. So it's going to include all values from 0 to positive infinity in the range. The y-intercept will always be at 0, 1. Okay, so it doesn't matter if it's 2 to the x, any value of b that you plug in, you're going to get 0, 1 as the y-intercept. Let's see why that happens. Remember, the y-intercept occurs anywhere x equals 0. So if I go to this function, if I plug in x equals 0, I get b to the 0. And remember that anything to the 0 power is equal to 1. Okay, so that's how we always get the y-intercept at 0, 1. The point 1b is always going to be included in the graph. Okay, so in this case, b is 2. So notice that the point 1, 2 is actually included in my graph. The reason for that is because if I plug in 1 to my function, I get f of 1 equals b to the 1. So f of 1, anything to the first power is just going to be that number itself. Okay, so anything to the first b to the 1 is just going to be b. So that's how we get that point 1b included in our graph. So now let's go ahead and look at an example and let's graph the function f of x equals 3 to the x. So the way to do this is to go to Desmos, and we're going to need these x values that it's asking us for, right? It's asking us for negative 2, negative 1, 0, 1, and 2. So let's go to Desmos, and what you need to do is you need to enter 3 to the x in this box right here. So you can do this on your keyboard. You can do 3 and then use the caret button to get the exponent, or you can use the keypad in Desmos. You can type 3 and then use this a to the b to get the exponent, and then type x. So let's zoom in and let's find those values that it was asking us for. So at negative 2, we are at 0.111, okay? At negative 1, we have the point 0.333, 0, 1, and then we have 1, 3, and then to find 2, I'm going to need to zoom out a little bit. Let's see, 2 is up here. You can see that at 2 we have the 0.29. Okay, so I'm going to enter all of these values into my table here so that I can recreate the graph. So we have negative 2, 0.111. We have negative 1.333, 0, 1, and then 1, 3, and 2, 9. Okay, so let's go ahead and graph this on our grid. So at negative 2, we have 0.111, which is a little bit above here. Then we have negative 1.333, which is about the third of the way above, right? So we're just going to put that there. 0, 1, and 1, 3, and 2, 9. Okay, so you may be wondering how I get an idea of what the shape of this graph looks like, okay? Remember to use Desmos to help you out. So like zoom in and kind of look at the graph. You can see that it's going to approach the x-axis, but it's not going to actually cross it. And you can see that it goes up like this. Okay, so you can get an approximation of the shape of the graph from Desmos, which you can use when you're sketching using these points, right? Because we need to connect these points to create our graph. So my graph is going to get really, really close to the x-axis, but not actually cross it. And this is kind of what it looks like. Okay, so now let's try this example. Let's graph f of x equals 2 to the x. Okay, so I'm going to jot down these x values so that I know what I'm looking for when I go to Desmos. And so now let's enter this function into Desmos. So we're going to clear this and we're going to say 2 to the x. And let's now find these points. Okay, so once it's defined at -3, so I'm going to zoom in at -3, and that tells me I have the point -3 and then 0.125. And then I have -2, which has the point, let's see, 0.25. And then I have -1, 0.5. And then I have, once again, the 0.01. And then let me go to 1. I have 1, 2. And then at 2, I have 2, 4. And then at 3, I have to zoom out to find 3. So I'm going to zoom out a little. And at 3, I'm at 8. Okay, so 3, 8. So now let's go ahead and fill in our table. So we have -3 and then 0.125. We have -2 and then 0.25. We have -1 and 0.5. 0, 1, and then 1, 2, 2, 4, and 3, 8. Okay, so let's go ahead and use these to graph our function. So at -3, we're just a little bit above at 0.125. -2, we're about a quarter of the way above. -1, 0.5, so about halfway. And then 0, 1, 1, 2, and then 2, 4, and then 3, 8. Okay, so before I start connecting these points, I just want to check back with Desmos and make sure that what my graph looks like. Notice it's going to approach the x-axis, but it's not going to actually cross it. It may be easier to see if I just change colors here. So you can see the graph in blue is going to get really, really close to the x-axis, but not actually cross it. So I'm going to use that to sketch in my graph, right? Connecting these points. So it's going to look like this and get really, really close to the x-axis, but it's not going to actually cross. Okay, so that is approximately the graph of my exponential function. So now you can go ahead and pause the video and try this example on your own. So we have 2/3 to the x, okay, so we have also, and we're looking for the x values of -2, -1, 0, 1, and 2. Okay, so once again, we're going to go back to Desmos and use Desmos to help us out. So we're going to clear this, and then I'm going to do parentheses, and then 2, and then you have to use the divide for fractions. So we do 2 divide 3, and notice it just automatically makes it a fraction. Then close the parentheses, and then use the a to the b to get the exponent, and then do x. And now let's find these points that we're looking for. So we're looking for -2. So at -2, if I click here, I'm at 2.25. At -1, let's see, let's zoom in. -1, we're here at 1.5. At 0, we're here at 1. Let's see, 1, if we click on that, we're at 0.667. 2, we are here at 0.444. Okay, so let's go back to our table now and let's graph these points. So we have -2, 2.25, -1, 1.5, let's see, 0, 1, and then 0.667, and then 0.444. Okay, so I'm going to go ahead and plot my points. So I have -2, 2.25, -1, 1.5, 1, and then 0.667, so a little bit more than a half, and then 2, and then 0.44, so a little bit less than a half. Okay, once again, I kind of want to get a big picture overview of what my graph looks like when I sketch it, so I'm just going to zoom out in Desmos. Notice it is a downward sloping graph. It's going to approach the x-axis, but it's not going to actually cross it. So I'm going to use that to go ahead and connect and fill in my graph. So it's going to go like this, and then it's going to go up in this direction. Okay, so that is about the graph of f of x equals 2/3 to the x. So remember, to graph exponential functions, you're going to start off by entering the function into Desmos, or you can use your graphing calculator. Then fill in the table using points from the graph, and then plot the points on the grid and connect the curve to form the graph.